Okay, today we are going to, this is actually a great topic. It's a great topic because in M&V for ESCOs, I mean, you know, we talked to Steve Cromer last week and he was talking about all this new stuff for M&V, but most of that new stuff was for utility sector. It wasn't for us ESCOs. For the ESCOs, it's pretty much the same as it's always been. It's pretty much the same. There's not that much that's new except for what you're going to hear today. This is, and it's not new, it didn't show up last week. They've been doing this for several years, but I think it's something that everyone who does M&V really needs to know about, because this may be the solution to a lot of problems that you run into. And it also may be a good way to develop your M&V plans, integrating what Ricky's going to tell us about. So that's what I've got. Actually, I don't know too much about Ricky. I'm going to let you introduce yourself.
Sure.
But Redaptive has been around for a while. In fact, he'll introduce Redaptive as well. So go ahead, Ricky. Tell us what you got.
Great. Hey, thanks, John. A little bit about myself. I've been working in the energy services space for 15 years, helping enterprise leaders reduce their energy consumption and kind of achieve superior economic outcomes. That's kind of the space that I've triangulated on. And I've been with Redaptive 5 years and really helping to build out their technology practice. And so we're a multifaceted energy services company. We've got a performance contracting division, and we've got a smart sensor and energy analytics division. And so I lead the second group. Mostly our business model is around helping kind of C&I, commercial and industrial enterprise organizations achieve, deploy sustainability, cost reduction, power generation technologies across distributed real estate. So that's a space that we occupy. Today, what I want to talk to you all about is some of the M&V pain points that we've encountered. And so we ended up building out a solution in-house, but now we've offered that a lot to other ESCOs and other enterprise organizations to solve some of their pain points as well. And so I want to talk to you about, I don't want to talk about our solution. I don't want to make this a commercial. Rather, I want to talk about what I'm seeing in the space. What are some of the new tools that are available to make better decisions and help move some of the roadblocks that traditionally M&V professionals have been encountering as pain points? And so I want to talk about those. I've got some good case studies around where we had some great success. And I want to make sure that we have plenty of time at the end for some questions. But I guess before I jump in, I've served in a position where I've done measurement and verification, defending underperformance from performance contracts in the past. And I kind of think about M&V professionals as soccer goalies, right? When everything's going great, there's no pain. You don't hear, there's no noise. You don't have to worry about anything. But when things don't work out, you're the last line of defense. Everyone's looking at you. And so you've got this challenging dynamic that you have to contend with. And so some of the pain points I've outlined here, there's a lot of different issues that I'm sure that you all encounter. But some of the problems are things that are out of your control, right? And so the traditional ways that you do, option C, M&V, or you do whole building analysis, you lose a lot of granularity. And I'm going to talk about some of these different pain points that I've encountered in the past, and some of the ways that we, and within Redaptive in particular, have tried to address this. And I think that hopefully for you all, you can kind of glean some best practices that you could use, or at least when you're evaluating other solutions, think about what are the questions you should be asking. And so, one is around granularity of data. So you do a lighting upgrade, you're trying to isolate savings around lighting, and it's hard when you're doing whole building analysis because there's a lot of other confounding systems in that building. And so how do you kind of isolate based on the systems you upgrade? And so that's one way that we're using the sub-meter data, circuit level sub-meter data, to help kind of isolate that level of detail. And that really hasn't been possible before because it was really challenging. It was expensive. It was difficult to scale. It wasn't resilient. But some of those dynamics have changed with kind of the broader adoption of IoT tech and lower cost sensors available in the market. difficulty accessing the data. So once you install the systems, how do you actually get that information out? How do you turn it into usable information that you can kind of either use for M&V or use it to identify other opportunities or do maintenance-related insights? And so getting the data in your hands was hard. But now, because you've got so many connected devices, you can actually pull it to your servers in a secure way, and you can manipulate the data. And there's a lot of software platforms out there too that can help you do that in a broad spectrum of different robust kind of analytics that can be automated. Inconsistency of data. So with any energy analytics, it's garbage in, garbage out. And so how do you make sure that you're getting clean, good data so that when you're doing your analysis, you're actually getting the results that you expected, and then you're not defending bad data, because that's a horrible place to be. And then the last piece is, how do you make sure that you get all of the measurement that you need, right? And so, when the sales team is constructing and solutioning the project, and you're trying to make the deal work, a lot of the M&V related instruments get removed early on, right? It's the first thing to go when you're trying to cut cost out of these projects. And so how do you find the right solution that can get to, call it sub 5% of your project costs? So those are some of the things that we've seen. There's also some really cool tools out there around reducing installation errors. So just like I was saying, garbage in, garbage out, if the root cause of the bad data is the installation of your measurement systems didn't take place correctly, how do you make sure that you figure out the issues early on in your cycle, and so you're not kind of playing catch up after a problem ends up emerging? So here's kind of the ecosystem of solutions that we look at, right? At the top, you can see kind of the traditional metering system that you've encountered in the field. You have to, and you all must be familiar with this, right? You have this external enclosure, you have to run conduit, you have to drop a plug point, you have to set up some sort of networking, whether it's in building or some sort of gateway. And you're capturing some level of circuitry inside that panel, but it likely is not every single circuit. And so this dynamic is one that we had to contend with early on in kind of the Redaptive life cycle. And the challenge with this is it was expensive. So it was about $7,000 to $10,000 installed was our kind of price point we were contending with. And it didn't scale well. So when we were upgrading buildings, let's call it hundreds of buildings, it just took forever to install them. And so we needed, instead of selling our customer on our primary project, we had to sell them on the primary project plus the secondary metering project. It was just a high degree of friction with our customers. And so we're like, there's got to be a better way. And then once we got it installed, it would go offline, and somebody would mess with it, or the cleaning crew would unplug it while they're polishing the floors, and it wouldn't get plugged back in, and we'd lose data. And so there was all of these like human elements that stopped us from being successful. And so we ended up building out our own solution to kind of solve this problem. And so we synthesized this whole kind of external architecture into a simple 4-inch by 10-inch box. It goes inside of an electrical panel, and it's able to do high granularity of metering. So you're able to capture every single circuit inside that panel, and it can go at a branch panel, it can go at a building level on a main distribution panel, or it can go on a specific asset. So you can put the metering solution on a chiller and capture all the component loads. And it's all about bringing clarity of the data, right? And so instead of just getting building level load, you can start to get asset level load. And so you can easily isolate, again, I'll use lighting as a simple example, but we get very complex here. But with lighting, if you do a lighting project, you need to do M&V on lighting. You can isolate the lighting circuits and not get all of the confounding temperature dependent changes in consumption that impact the utility bill. And you don't have to explain that to your customer at the end of the day. You can isolate based off of the specific measure you upgraded. And so that that saves us a lot of heartache, and it makes it easier for us to sell highly scrutinizing customers. And in my case study, I'll talk about a CFO who was really needed high degree of auditability, and this allowed us to kind of overcome that challenge.
I want to interrupt for just one sec, Ricky. So
Yeah.
where this could really work really well is on package units and stuff. Sometimes if you have a lot of package units and if they're all in one panel, you might be able to monitor a lot of package units or a lot of pumps in a chill water plant or something like that. That's another application. The reason I mention that is a lot of ESCOs pretty much think that they've got the lighting, and they got the lighting figured out, and they don't monitor it. They do it a different way. They just measure some fixtures before and after, and assume schedule, and they're done. So lighting isn't their big deal, but there's other technologies like package units or pumps or things like that where this is going to be super effective.
Yeah, good point, John. I mean, so if you think about a mechanical panel where you've got you might have 5 to 10 RTUs in a single panel, and we're able to capture all of those with a single meter. So one of these meters is able to capture 48 loads or 16 three-phase circuits with a single meter. And so you're able to isolate the specific equipment, and you can kind of mix and match across an entire building. So you'd be able to capture 5 different panels. You might be capturing 15 or 20 RTUs, and you stitch it all back together in a single platform. And so that makes it really easy to analyze in one place, and you're not finding yourself in a position where you're putting sensors all over the building, and you have a high, like the resiliency challenges associated with that are high. The other piece is outside of just looking at energy, you're looking at power quality, you're looking at power factor, and so you can start to do maintenance related insights. And I'll talk about besides just M&V, what are some of the other kind of primary use cases that we're selling our customers on that they're paying for, right? And so these are additional value added services. And then how do you get the data? So each one of these sensors, and again, I'll talk about our solution, but at the end of the day, there's other smart metering solutions out there in the market that are now connected, right? And so they're cellular connected devices. They're not necessarily, you don't have to touch the customer's in-building network. And so that's a major pain point too, is like, how do you avoid engaging an IT department when you're selling your energy project? Because now you've got another stakeholder that you have to sell on the program implementation. And so a lot of these solutions have embedded cellular or have 5G that can allow you to extract the data directly out of the building. And so that's one major piece, because now you don't need a networking technician and an electrician to both implement the solution. Like that, then you're having to secure less resources and it's less coordination. And then once you install, you get the measurement, getting the data out of the building, how do you access it? And so there's a few different ways that you should think about accessing the data. Is the platform is going to give you access to an API, so you can just pull it into your existing analytics platform. And so an API is an application program interface. It's a way for you to access the raw data feed platform within your organization. It's a way for you to get easy data. The other is if maybe you're just used to working in Excel, right? And so make sure that you have easy access to be able to get Excel downloads, so you can manipulate the data easily, and you can pull it into your platform and pull it into your system easily. And then the third is if you don't have access to a platform like that, there's web-based software platforms where you can do some really robust energy analytics, measurement and verification, performance reporting that can produce great outputs for your customers. And so those are kind of different ways that you should be able to receive the data. And so when you're evaluating systems, and I'll kind of talk about what are the things you could look for, those would be the things that you should think about. And those are, a lot of these web-based smart systems have at least 2 or 3 of these available. So outside of just the measurement piece, a lot of our customers are starting to do more and more around ESG reporting. And so if you think about, the audience is not just a CFO, but it's a head of energy, it's a head of real estate, it's a head of sustainability. They're trying to find ways to do streamlined ESG reporting. So once the meters are in place, it helps them to get that data in an easier way. The other thing from an ESCO perspective is you're looking for ways to sell your next wave of projects. And so how do you turn the measurement verification part of your cost stack into something that's a business development function? And so we're starting to use the data to identify the next wave of projects. So for example, you're scaling an RTU upgrade across your customer's portfolio. You know that the next system that they're going to be looking at is solar or air compression. And so you meter a project ahead. And so because the cost per sensor is getting lower and lower and lower, it incrementally costs very little to add additional sensors. So for us, we'll always meter a project ahead, and so that we can start to build the business case around the next program. This is critical because now it's easy to justify the 5% additional cost of M&V because it's going to help us sell the next wave of work. Now you're looking at that 5% and you're comparing it to the next $20 million project you can do with that customer, and it becomes easily justifiable. So using this as a leverage point for project identification is a big kind of forward step. And then the last is maintenance and equipment monitoring. And so while you're monitoring all these RTUs, you're doing consumption monitoring on your chiller systems. How do you make sure that those systems don't go into disrepair? And so we're looking at data in sub-second intervals. So you might say, why would you look at sub-second intervals? That's crazy. That's way too much. But if you're looking at 15-minute intervals, you can see that the RTU is consuming X amount of kW. If you're looking at sub-second intervals, I can tell you that the compressor is misbehaving, that the fan belt is operating irregularly, that there's irregular voltage, and so you might be 9 days away from a failed rooftop unit. That's the way that you can start to add value to your system and your ecosystem, and particularly in a performance contract where you're responsible for maintaining the equipment. Here's just an example of where we've had had some pretty great success. We scaled the solution across a large Fortune 50 telecom company. And so there's over 700 locations that we scaled across: office buildings, switching centers, retail facilities. So like a broad spectrum of different asset classes. And the CFO was really contending with the measurement and verification methodology. They just didn't believe that they had trust in the outcomes if we used option C. And so they wanted greater degree of auditability on the savings we produced. And so here we did lighting upgrades and we did building management system upgrades. We did retro commissioning as well as part of a broader program. And it was kind of critical that we implemented circuit level metering. And so we scaled kind of this sub-metering solution across the full portfolio. We did pre-metering for every single site. We implemented the measures, and then we did post-measurement kind of reporting on every single month thereafter. So it allowed us to bill on actual savings, and we had a really easy way to kind of create a baseline and give full degree of transparency to that customer. So we've now been working with them for over 6 years. We haven't contended with any sort of disputes around the payment structure. So I think that kind of is testament to the fact that the solution has ended up bringing the level of transparency they needed. And it scaled easily. So now on the next phase, we're using the data to help continuously optimize their building management systems. So we monitored a lot of their RTUs using the data. We're now feeding this data back into their building management systems so that they can adjust set points and they can kind of optimize around making sure that their systems don't go out of band. So this was a great success. And I've got a bunch of other different case studies. So in Q&A, if you have any questions around, you've got specific customers, whether it be, different asset classes, I'm happy to talk about those as well. It's the last piece I want to leave you with is, how do you think about these systems and buying these systems? And so as you look at the market, there's a few things that you should keep an eye out for. And the first is around accuracy. And so a lot of the smart meter systems are designed for scale, but many of them might do so at the cost of accuracy. So I would say look for a solution that has measured voltage, meaning they have a voltage tap. They're instead of using like an assumed voltage factor. What we found in the data is that you can have 15 to 25% swings in accuracy if you're not capturing voltage correctly. And so it's kind of critical to make sure you isolate that. And that's not always available in all solutions, so something to look for. The next is make sure you can get the data easily. A lot of them are using in-building network, and that could be great, but it just means that you're beholden to your customer to access the data. So to the extent that you can get access to the data via remote operation, so you could have maybe they're cellular connected where you don't have to necessarily route the data through the customer's servers. It gives you better kind of control of your own destiny. The next is versatility. And so make sure that you can install that same solution in all locations. So if you're looking at capturing chiller data or lighting or air compression, or you want to move it onto an individual asset versus a branch panel, try to find a solution that can accommodate all of those, because mix and matching solutions and trying to pull the data back into one place could be complex. And then the last is, and this is one that's becoming increasingly fascinating, which is around making sure that you've got high quality data, both from a labeling standpoint and from an installation standpoint. So because you've got access to a lot of this data in the cloud, you can analyze the data and say, all right, did this meter get installed correctly? Was the voltage tap installed correctly? Are all of the current transformers installed frontward facing and not backwards, so you're not getting negative readings? And so you can start to do that in an automated way so that you can kind of ensure that the installs took place correctly, as opposed to figuring it out 9 months down the road when you have run into an issue. And then the other is making sure the labels are right. So without having to go through like a very challenging circuit tracing exercise, you can start to look at the energy signatures of the circuits and start to auto classify what systems those are tied to. So for example, if something is labeled a lighting circuit, but it's modulating based on outside air, you can auto classify those as HVAC circuits. And so that dynamic is something that's increasingly being ingested into these platforms using AI. So something to look for. And I think that, you know, more and more of these systems come online, you're going to see them beyond just electricity. You're going to see them in water and gas. I think electric is kind of the tip of the spear in the industry.
I've got a lot of questions.
Yes.
Can I start? All right. So first off, there's a couple things that I really want to mention that are really important for us ESCO people and M&V. So one is, if you something like this might be really useful. Let's say you're not going to use this system to actually track energy savings. Let's say you're going to do option A, B, or C. I don't care, whatever, M&V. But this is still really useful, even if you're not using this to track energy savings. And the reason why is this is a great way to track changes in usage patterns. This is great for that. So what if now their lights are on twice as much as they used to be? Now they're running them all night. Well, you know, you might not know that unless you go visit at nighttime. A lot of times the facility managers won't tell you anything. But if you're monitoring this, you'll see it. You'll see it. It won't be on the BMS probably. And so that's what's really nice. Or, you know, maybe they have new plug load or something like that you didn't know, but they, you know, added these, I don't know, new plasma TVs or something that's adding a lot more load. Now you can isolate it. And that is what I think is super important about this technology, that it doesn't matter if you're doing option A, B, C, or D. You should install this anyway, because then you can track what's going on in the building. But the problem is, let's say you're doing a big hospital, it's, you know, 300,000 square feet. How many panels do they have, and how much is this going to cost? That is the next question. So, Ricky,
totally.
What would this cost for? I mean, I don't know what other people charge, but I mean, well, let's even back up. Redaptive sells, you can just go buy the stuff from Redaptive and from these other companies as well. You can just go buy the solution itself, right? You don't have to be involved in your ESPC or any of that stuff. You just buy the equipment.
Totally.
Okay.
Yeah, that's right. So I'm going to address your 3 points you brought up are great ones, right? The first one is you use the data to figure out how is that building actually consuming energy. And so, you know, when you a lot of times it's an assumption-based approach. If you're surveying your customer to say, what are your hours of operation, or how long are you running these systems, your customers don't know. I mean,
right.
Invariably it's wrong, right? And so, like, it's very challenging to come back later on and say, you know what, you didn't realize that the cleaning crew came in and turned on all the heating and cooling units at 2 in the morning, and so you're tempering your space for 4 additional hours than you realized. Like, that dynamic ends up being challenging to contend. Now, when you're monitoring, it's easy to come back and say, look, here's exactly how much you consume. And by the way, you went from a 2-shift operation to a 3-shift operation for these 2 months. And so we need to adjust our savings parameters based off of that. It becomes really easy to kind of isolate that dynamic. So I think that's the piece where we've ended up bringing ourselves to the same side of the table as our customers when we can bring that level of visibility.
Mm-hmm.
Your other question around, do we sell the stuff? We do. So it's available. We have 2 different options. You can buy like the meters as widgets, as appliances. And then there's a data package that allows us to kind of provide that information to you, again, in those different kind of data delivery formats. Or we can structure it as a service, right? So if you've got a performance contract that's 10 years, we can align with that 10-year contract structure so that you're not absorbing all that cost on day one. So we have a mixed process. And then the last, I think, is, how do you price these things? And so it's all around meter design strategy, because there's a value engineering mindset here, right? You can't go overboard. You can't make this thing blow up the project. You can't be 25% of project cost doing M&V. How do you get to below 5%? And so there's a few different strategies we employ. We typically, when it's something like when there's homogeneity in the portfolio, there's a couple of ways we could address it. We might say, hey, if every building looks the same, we're going to do a sample set, which represents 20% of the buildings, and they represent the whole. And so we might do high granularity in that 20%, and a lower degree of representative for the remaining 80% tail. That might be the structure that we employ. Or if it's something like a hospital, we might do either we're metering everything in the hospital. And so that might be, I'll give you an example. We've done 50 hospital projects. In some of them, we've metered 50% of the hospital, okay? And so it might mean 150 panels of their 300 panels that we're monitoring. It's roughly, just to give you a ballpark, call it $2,500 per panel. That would be a way to think about it. Okay.
That's good.
So prices can be substantial in that regard. On other ones, we're like, that just won't pencil economically. A way that you can look at it is we'll find representative areas of the hospital and we'll just monitor those. So let's just say it's a 10-story building. Each floor of that 10-story building operates relatively the same. We might monitor 2 or 3 of those floors, and it represents the entire building. That's kind of and then you come to an agreement with the leadership, and then that's the methodology you lock in.
Okay, but it's $2,500 a panel, more or less. And does that include the data also, or is that just for the equipment?
That'll include the equipment. That'll include typically the installation, and then the data ends up being kind of a variable structure based off of what type of services you're getting.
Okay. And if you
but it's pretty inexpensive. So just to give you kind of like apples to apples, like I think when we started in the market, it was about $7,000 to $10,000 was the typical install. We got that to like a third of that price. So that's kind of where I think we occupy a pretty unique spot.
So some folks, I don't know if you know, we sell this M&V Option C software, and I'm not suggesting any clients use our software or don't use our software. This isn't a sales deal, but some might want to be consistent and continue using it. And I think what you could do is actually take this data and then put it into Excel, or actually and then from there you can import it into the software. It's a regression software. That's all it is. It just does regression.
Totally.
And savings and stuff. So, but yeah, to do it into
that's it. So we don't want any of our customers to be beholden to our software. At the end of the day, it's like, how do you get access to the data in the easiest way possible?
Good. And if you wanted just to dump into Excel or into CSV, then you still have to buy a data package or something like that?
It would still be a data package, but it's a cheaper package.
Okay, got it.
Mostly the data package exists because all the meters are embedded with cellular, so there's like a cell card that's attached. And so most of it's tied to like the data transmission cost.
Okay, I'm just going to assume that your prices are representative of the industry, because I don't know what everyone else charges or how good or bad anyone else's stuff are. But for now, I'm just going to make the assumption that everybody's charging about the same. Okay, so one of the good reasons I mentioned before is you would install this beforehand in some projects, because then you would be able to identify changes in usage patterns. And another reason why would be if you're just putting in package units, let's say, that's all we're doing. We got a school and we're just doing package units and lighting. And maybe they did the lighting using Excel spreadsheets, but the package units, they had to monitor the savings somehow. You know, you can do this where you just take the readings from the package units, and then from that you can do regressions with weather, and you've got a baseline. And so
That's
this way
exactly.
you can ignore everything else, and that's what's so nice. It doesn't have to be. I never liked that they called option C whole building, because it wasn't ever a whole building. It was meter based. It should have been called whole meter. And you can do option C with just a portion of the building, with just some equipment that you are monitoring with something like this that Ricky's talking about.
Yeah, I mean, look, I think every person on this call has probably encountered a situation where they're monitoring a piece of equipment or a single system, and the customer's like, well, you told me I was going to get 10% savings, but my bill went up by 15%. Like, why is this happening?
Exactly.
And because there's 9 other things that happened in that building. They ran an extra shift. They have another piece of equipment. And so, you know, it was more warm days than cool days than expected. And so all that dynamic ends up putting you on your heels. So if you can isolate the system, it becomes much easier.
Yeah, that's good. I did have a comment from someone in the crowd, and they said, you know, one of the problems that we have, like when you're trying to isolate just lighting, I remember I did a bunch of department stores once, and their panels were totally mixed up. Actually, their circuits were mixed up, but you know, you would think it's just a lighting circuit, but it was lighting and plug load and maybe some point of sale devices also. And they were supposed to be just lighting. But, you know, these electricians come in, they do the quick job, and, you know, that's just how they do it at times. And so when you're trying to do this, you know, for your telecommunications company or someone, and you're just trying to do the lighting circuits, often it's not just lighting. You end up with a lot of plug load in there as well and other stuff. Is that correct?
Yep.
And how do you
Yeah,
deal with
so awesome question. So yeah, you've got commingled circuitry at a lot of these. And so what we'll typically do is we'll scale through, and we're not going to meter we might not necessarily want to meter every single panel in the building, right? Because we're trying to value optimize here. So we might do 70% of the panels. Now, while we're capturing 70% of the lighting circuits in the building, that might be that's our critical mass to be able to be representative of the whole. Then what we'll do is we'll use machine learning to look at the data and say, all right, are all of these lighting circuits behaving like lighting circuits should? And so we'll flag which circuits have commingled circuitry, right? So like I mentioned, if they're modulating based off of outside air, we might de-scope that single circuit and say, you know what, this one has got something else on it. It's got an RTU on it. Let's peel that outside of the scope.
Okay. I was wondering, now I don't know if this is going to be possible because you're doing this on the fly, but can you show a picture of a device hooked up to an electrical panel or something like that? Do you have any pictures on your computer that could show that?
So actually, yeah, I think I had one in the deck here. Let me just jump to it real quick.
Okay.
So what you can you see my cursor moving?
Yes.
All right. So here's what the meter sits. Here's a typical branch panel. Okay. The meter actually can sit inside of the panel. Okay. Now, the reason that being inside the panel is so great is it's out of sight, out of mind.
That's right.
When you have an external enclosure, there's the human element. People mess with it. People will play with the rabbit ears. People don't know what it is. They unplug it. They, like I mentioned before, the cleaning crew is going to plug in the floor polisher and they never plug it back in, so you lose connectivity. When it's out of sight, out of mind, it's inherently tamper resistant. And then what it does is then you've got these snap-on current transformers, which can connect to each of the individual breakers inside this panel, each of the individual circuits. And then you've got an embedded cellular so that this panel is transmitting to the cloud without touching the customer's in-building network.
Okay. Yeah.
So just to give you some idea of labor too, this is about 5 hours to install. This is typically less than an hour. So like a lot of that, one thing is cost. The other thing is like customer friction. How do you get out of your customer's way? And this was a big win for us because this solution, the customer didn't see a lot of value in it, but they felt like it was really annoying.
Oh, okay. And so, yeah, by putting it inside, it just takes 1 hour more or less to hook it up and put all the CTs on and everything.
That's
Okay.
right.
Okay, so I have a question in here about how you handle establishing a baseline or measuring performance of HUs or RTUs. Now, because they have chill water, so it's you know, I might be able to answer some of this, but I'll listen to you answer it too. So we have chill water coming into the unit, which that temperature may vary, which means that the fan speed may vary. Let's assume it's a VAV system. So the fan speed will vary based on the temperature of the chill water, and then also there's outside air temperature varying. I wondered if you had an answer to that. How would you use this system to monitor HUs?
So there's a couple of things. One is we might marry this data with other sensor data that we're getting from the BMS, right? And so if we want to do, we'll typically bring in other building sensor data, which might have the flow information. It might have the temperature sensors for the chilled water system. And then it allows us to kind of establish like a critical baseline based off of the current production time, the time of year, or what month that they're operating. And then we'll do some sort of temperature-based linear regression for weather normalization. That's how we'll do our predictive analytics, right? Like that's the way that we would kind of typically march down this. But again, with a lot of our ESCO customers, we'll be an input into a number of their different solutions, right? So they have their own methodology. We're just going to give them the data set that plugs into their existing model.
Right.
We're not necessarily taking on the M&V calculus. That's not like our core business is to perform the M&V. It's just to give them the access to the data.
Right, right. Yes, my answer is kind of part of what you just said, and that would be probably maybe they're using bin simulation spreadsheets now, and you're just going to put this data into it. I mean, that's it. That's just going to be the fan kilowatts. It's going to go right there, and that's based on outside air temperature. So it's those two. You're only measuring those two: outside air temperature and the fan kilowatts. And yes, the chill water is changing, but you might actually, that would be all I would do. So we would, I guess, make assumptions when you do bin sims that the chill water, if it's only 40 degrees outside, well, the chill water temperature is always going to be the same temperature when it's 40 degrees outside.
Yep.
So those are assumptions you make sometimes when you do these kind of calculations. But that's,
right. Or what we'll do is we'll start to kind of track KWH consumption or KW consumption in various temperature bins. And so we start to bin each of those individual kind of temperature segments, and then you can start to kind of map that out against expected heating and cooling degree
there you
days.
go. Yeah, we're saying the same thing. Perfect. Let's see, we have more time, so I'm gonna see if I got any more questions in here. Oh yeah, here's one. Does this panel, let's see. Okay, yeah, so can you do this with solar or renewable, like windmills, inverters? Can you, I guess, attach it to these systems to monitor energy data? Yeah, or also, can you get any kind of alerts as to whether or not the thing's not working anymore? I assume the answer would be yes, but
that's right.
Renewables?
So for first question, for solar, what we'll typically do is from the software side, we'll pull data in from the inverter. So we'll work with an Also Energy or whatever kind of whatever solar provider that you have that ends up producing that data set. We can pull that into our software via API if there's an existing meter. Where this marries nicely is if you've got the inverter that's kind of measuring the generated kWh. Then you've got a sub-metering solution that's measuring the in-building consumption. And so when you marry those two, it allows you to kind of appropriately size any sort of storage system. So I think that's where we're seeing a lot of traction, is being able to stitch together kind of really robust storage proposals, because we've got both of these data sets, which nobody else has. That part is kind of a fascinating strategy.
Okay, I got a great question. This is a question that's come up a lot, because I've kind of like, we haven't installed any of these, but we've come so close sometimes. COVID killed the project where we were going to do this, and dang COVID, and then, well, whatever. But this was one of the problems that we anticipate running into, and that is, how often do you, and what do you do about running into rooms like electrical rooms with panels, and they don't, you can't get cellular there, or there's no Wi-Fi that goes there. How do you
Totally.
deal with that? What do you do?
So a few different options, right? Your typical cellular isn't going to work in a lot of electrical rooms. So we've got a few solutions. One is the meter has got an embedded Cat-M module, which is like, it trades bandwidth for signal strength. So you're not streaming Netflix on the meter, but you are getting about 5x the connectivity that your typical cell phone would. So that's one thing. Two, if it's still not connecting, we can run a line antenna. So you run like a physical line antenna. You can change the location either in room, or you'll drill through a floor and put it in a new room. Three is if you're still not getting connection, what we'll end up doing is connecting to their in-building network. That's usually the last result, or the last resort, just because we don't want to engage their IT, right? But we can run a Cat5 and connect to their in-building network. And I guess the fifth thing is if we wanted to maybe change cell phone providers, we might have an additional modem where we'll pick up different SIMs for different carriers who might have better connectivity.
Here's a question. How about if an ESCO wanted to do this, do they, I mean, do you have I think you might have answered this, but I'm just gonna make sure. Can they just contract with you or one of your competitors just to go in and just do it? They'll say, look, I need these panels, these circuits. In fact, I marked them all with red, tape or something. Go do this. Or do they just buy the equipment and then watch some videos and do it themselves?
We do both. We have a turnkey, and we've got just a product sales piece. So we work with our customers in both ways.
Okay. Oh, and one thing I want to mention to the ESCO folks, look, I hope I'm not sounding like a shill. I'm not trying to sell you anything. I'm just trying to explain that this is something that's a good addition to ESCO M&V practice. That's it. I'm not saying you have to buy from anybody, but God dang it. And I went and said that and I forgot what I was going to say. Oh, so sorry. Okay, I'll remember in a minute. Let me get to this one.
Okay. You know what I will say is just to kind of talk, just to make this a little bit more balanced, right? I think we've got an awesome solution, but some of the other solutions that are out there have different architectures. So what our solution favors is you want to get many pieces of equipment in a single panel. So we have a meter. You can capture all 48 pieces of equipment in that single panel. Some other architectures out there are better designed to capture few assets in a bunch of different panels. Mm-hmm. So like, if you've got 3 chillers that you want to capture and that's it in a building, there might be better architectures than ours to be able to kind of bring all of those sensors across those 3 chillers into a single gateway, and then it transmits out of the building. And maybe you might need less, it might be less cost to do that. Versus ours is a better solution if you want to get many pieces of equipment in the building, and it allows you to do that in a low-cost way. So I would think as you build the business case, like there might be different architectures that you should look at.
Okay, that's good. That's good. And now if someone called you and said, look, this is my issue, I wanted to do exactly what you said, this thing over here, this over here, and this over here, but not all in the same panel, would you be able to direct them to other companies? You'd mention their names and tell them where to go?
Totally, yeah. I mean, at the end of the day, we want to help our customers and we want to be good partners across the board. So they'll come back around to us for the next one.
One thing I wanted to mention is so Redaptive, they call themselves an ESCO, but they're not really traditional in that they don't really, as far as I'm concerned, maybe I'm wrong, but I don't think they really operate so much in the same space as JCI and ESG and Siemens and those folks. They're really, a lot of what Redaptive does is, like he said, commercial and industrial. Whereas the traditional ESCO model is federal, or it's government, so it could be small government, it's schools and it's hospitals. So they mostly it's kind of mostly in a different market. You mentioned you do some hospitals, but some folks, every once in a while you're gonna run into ESCO folks that don't wanna use the competitor's product. I wanna think these are your competitors, but that's just why I brought that up.
Yeah, and I think, look, it's a cooperative ecosystem because JCI brings us into accounts all the time as partners, by way of example, and we might acquire, and we might implement carrier package rooftop units into our project or train package rooftop units into our projects.
Right.
And so
Right.
the ecosystem is symbiotic, right? And so there might be opportunities where it's competitive, but at the end of the day, like all of us play in a collaborative, cooperative, frenemy space.
Yeah, there's a lot of buildings out there. Okay, so here's another question. Would you put a meter on the meter main, any generation assets, and then go down to the granular circuits as a standard operating procedure?
Yeah, good question. We typically what we'll do when we do a project is we'll do A, the building main, and then B, the main system of interest, right? So like the system of interest might be more granular. And it depends on like the architecture. So if you think about it like the electrical infrastructure of the building is like a hierarchy, right? We'll capture at the main meter or at the main distribution panel. Now, because we can capture 48 loads off a single meter, we can capture all of the phases that go to the branch panels off that MDP. So if 16 branch panels come off of that MDP, we're actually able to capture all 16 of those branch panels from that single meter. Right. So there's a lot of insight and granularity you can get even off of a single solution. It's just about architecting, finding the right architecture based off of its infrastructure.
Okay. Here is one. This is a great question, actually. I'm not saying some weren't great, but this one I like because it's a great question. How does Redaptive, your solution, differ from hobo loggers? So this person here is installing hobo loggers on lighting panels. They cost about $1,000 per logger. Well, I don't know if they cost $1,000 per logger. Maybe they are. Maybe they're really fancy ones.
So tell me if you've, I guess, the one thing about our solution is it's persistent, right? So it's there for the life of the contract. You're continuously monitoring that circuit. You can get the baseline, and then after the project is done, you're still there. And the reason that that's good is you're continuously being able to deliver the data, and you're not sending somebody physically to the premises to go and conduct the measurement. The other piece, so that's labor cost reduction. The other piece that a lot of our customers, their challenge with hobo loggers is how many times have you gone, take the reading, you get back, you put the chip in, data is corrupted, or it's incorrect, or it didn't load correctly, and now all of a sudden you're just jammed. You have to go back. You missed your window because you needed to do precondition monitoring, and now the project's taken place, and you've missed your window, and now you're in a tough spot. So all of that, I think those are some of the challenges that we've overcome. I think with this solution.
Yeah, I don't know. I mean, maybe these hobo loggers, because you said there's $1,000 each, so maybe these aren't the typical loggers that cost $100. So maybe these are. These ones might have some kind of Wi-Fi or cellular. I don't know. I don't know. Have you heard of that? If Hobo has that?
I mean, there is a bunch of meters out there. They typically will be 3 circuit meters, not 48 circuit meters. That might be the case. And again, the connectivity piece becomes a problem because if it's Wi-Fi, you're beholden to the customer. So if they lose connectivity,
yes,
what are you going to do? You can't hold them accountable. They have to hold you accountable. And so you can't control your own destiny, unfortunately.
Okay, that's good. Here's one. Can you elaborate on how the price point for install equipment is affected by panel amps? Let's say you want to install meter on a 3,000 amp motor control panel versus a 200 amp lighting panel. Is there going to be a difference in cost there?
Yeah, different costs based off of the CT mix. So as you think about the current transformers, 50 amp CTs are going to be like $30. 3,000 amp CTs will be like a couple $100. So you have to, there's a design element.
Yeah, that makes sense. Here's one. Is a solution available outside the U.S.?
We're in the UK market right now, in the Canadian market. There's some of our competitors have European products. So I've seen a couple of our competitors that have scaled through Europe. It's a little bit harder because in the European market, you've got so many different jurisdictions and electrical code requirements. And so that scaling in all those markets ends up being a little bit more challenging. Our next market that we're going to be looking into is going into Mexico.
What about the Middle East? Not yet.
Our solution is not in the Middle East. Actually, off the top of my head, don't have a great product I can think of for the Middle East.
Okay, let's see if I got anything else. That might be it. This is actually really good. This is a good talk. I guess they asked a lot of questions, so I guess maybe we have covered everything. What I want, yeah, so again, I just want to stress a couple things which maybe you heard me say, but I'm going to say it again. This is a good thing to put in your performance contracts at the beginning. So then you can identify where changes in usage patterns happen. It's also, it might even be good to put in afterwards as well. If you are starting to have problems with changes in usage patterns and you don't know where they're coming from, you might want to install the meters, and this will take care of later changes that happen down the road. You don't know what the baseline conditions were for that circuit, but you do know what they were like now. And so later on when things change, you've got some proof, and you know you can identify what it is. That's the biggest. I used to do this M&V stuff, and the biggest problem is the building, it's creep, the buildings use more and more energy as time goes on. And we don't know why. Is it this? Is it this? Is it this? And you ask people, no one knows. And it's difficult to find out why. And if you can find any tool that can help you identify that is something that every energy analyst wants, as long as they can, or any M&V person, as long as they can afford it. So that's it. Do you have any last words?
Yeah, I think the last comment on this is a lot of our customers are in the same shoes as you. They're doing measurement verification work. Either they're structuring a big project and they're trying to make the cost work, or they've been burned so many times they're looking for something that's going to give them an easier way for kind of defending their solution. So our team is kind of well equipped to handle and address those exact same problems. We're a pretty collaborative group, so love to chat with anybody if you've got specific questions or dig into greater detail. In the presentation, if it's going to be shared, I've got our sales team's email address, and then my personal. If you've got any questions, we're always available.
Good. Okay, so this is for Redaptive. Okay. Hey, thank you everyone for coming. We'll see you next month. Thank you, Ricky.
Yeah, great. John, thanks for having me.